Okay, now we're ready to go. Welcome back. I promised that we were going to pick up where we left off with those two problems that I had up on the board that were just solved for x. And I told you to come up with an answer to them. And I'm going to pull it up here and see how we did. Okay, so I'm going to go through and show you how I would do this, and then you can compare and see how you did it, and ask any questions if you want. I'm going to start with this this first one right here. The reason these are more difficult than the two on the top is we've got fractions going on, and nobody likes fractions. If you had an equation that had fractions and one that doesn't have fractions, it's usually easier to solve the one that doesn't have fractions, right? So one thing we'll want to do is just get rid of the fractions. The other thing you notice is when we solve for x here, like x only occurred once in our equation, so we could just get rid of everything else. Whereas here we got one x here, and we got one x here, and that one has a couple, and that one actually had three of them, so we have to gather like terms. And this is just about procedural fluency is what it is, okay? And I said we're going to spend some time solving these equations, but that won't be the brunt of the course. So when I look at a guy like this, I see a bunch of fractions right away. I know before I even start, I can write down x will definitely not equal what? There's a value of x that I know cannot be the answer. It's 0, right? Can anybody see why that is? Exactly. Let's say x was 0, hypothetically. Then it'd be 2 divided by 3 times 0, and 3 times 0 is 0, and 2 divided by 0 is undefined. You can't divide by 0. It's like one of our thou shalt not divide by 0 math rules, right? So I know for sure x cannot equal 0. So if I go through a bunch of solving process and I end up with an answer for some reason that x equals 0, I know that that's not my answer, right? When I look at this guy over here, I know for sure before I even start, x cannot be what? A little tougher. Can you guys do that in your head? What value of x here would cause this whole thing to be 0? Negative half, right? You see how we'd end up with 0 in the bottom? That's a bad thing. And then over here, negative third. That would result in a denominator of 0, so we don't want denominators of 0. So I know I can lay that out right away. So when I look at this guy, how do I get rid of all of these? The quickest and easiest way, there's more than one way to do this. The quickest and easiest way is to identify what we call the LCM, or the lowest common multiple of those three denominators. So if you remember your multiples and factors from middle school, lowest common multiple, if I have a 3, a 4, and a 6, my lowest common multiple of those three numbers is 12. It's the smallest number that all three of them go into. That's what a lowest common multiple is. So 12 is my lowest common multiple of 3 and 4 and 6, but notice there's some x's there. So I know that my lowest common multiple is actually going to be 12x. 3x goes into 12x 4 times. 4 goes in there 3x times. 6x goes in there 2 times. It's the lowest common multiple of my three denominators. Another way to say it is, instead of finding the LCM, the lowest common multiple, you might just want to find a common multiple. Maybe it's not even the lowest one, but as long as it's common, will help. It'll work. So I could just take 3x times 4 times 6x, which is like 72x squared. That would work too, as a common multiple. But you're just going to have a lot more work and a lot more canceling and a lot more things to do. So if we are able to find our lowest common multiple, we're usually good to go. So what am I going to do with that lowest common multiple? I'm going to take both sides times it. Whatever I do to the left, I can do to the right. So 12x times 2 is 24x. 24x divided by 3x is 8. See how nice and clean that cancels out for you? Everything works out. This guy I'm going to have to distribute, right? So I got to distribute to him, and I got to distribute to him. So 12x divided by 4 is 3x, and 12x divided by 6x is 2. And now I have a really simple equation that I can solve. I add 2 to both sides. So I say 3x is equal to 10. So x is equal to 10 thirds, or 3 1/3. Who got 10 thirds before you walked in today? Good. Should we try the other one? Same thing here. I'm going to look at my 2 denominators. I'm going to say, what's my lowest common multiple? Well, this time, the lowest common multiple and then any common multiple, it's just going to be the same thing. There is no lower one. So my lowest common multiple, my LCM, is just 2x plus 1 times 3x plus 1. So I'm going to take both sides times that. So if I take 2x plus 1, 3x plus 1, and over here 2x plus 1, 3x plus 1. Notice cancel. So all I'm left with is minus 9x minus 3 if I distribute. And on the other side, cancel, and all I'm left with is 8x plus 4 if I distribute. And again, now I've changed a complicated, ugly equation into a relatively easy equation. Now I can just gather my like terms. I can say negative 17x is equal to 7. So I think the answer is negative 7/17. Did I do that right? Anybody with me? You want to try a practice one really quick on your own? Let me grab one out of the textbook for you. Let's see, I don't have my textbook open here. I'm going to go to section, what we're on 2.2, right? No. Yeah. Let's try number, I'm going to go to the homework. Let's try number 80. Number 80. Let me erase this here. You can either open up your book or you can just look at the screen. Number 80 says, right there. Give you a few seconds, work it out on paper. When you're done, check your answer with your neighbor. See how you did. Identify that lowest common multiple. Show you what I did. You can see if you did the same as me. First thing I said is, before I even started, I could tell that x is definitely not going to be 0, because that would give me 0 in my denominator, and we know we can't do that. The other thing I looked at is I didn't even do the LCM right, did I? What is the LCM? It's 6x. I wrote down 12x. I should have wrote down 6x. But here's a good teaching moment. I did a wrong lowest common multiple, right? However, do you agree that 12x is a common multiple? So, did I still get the right answer? Yeah, I just ended up canceling more stuff than you did because you were smarter than me, and you did 6x and I did 12x. See how that works? So I multiplied both sides times 12x. If you were smart, you multiplied both sides times 6x. Anyways, you got everything to cancel down, and you ended up with x equals 6 when you were all done with it. So what are we doing here? We're solving equations. Nothing exciting, right? It's just practicing algebraic fluency is what we're getting at. So for any of these that involve these fractions, you can practice as many as you want. There's all kinds of variety in your textbook. For example, number 82. If I look at number 82, looks a little more complicated. But if you can identify your lowest common multiple, you can see that it's going to be x minus 2 times x minus 1. And if you multiply both sides by that, it's going to look really ugly and awful right away. But once you start canceling things, life's going to get a little bit better. So practice those. You guys know that you can use your solutions manual. I think, is it the odds have the answers in the solution manual and the evens don't? Yep. What you're going to find as you do some of these quizzes that I've given you on Blackboard, a lot of them are some of the problems that come right out of the textbook, except they're the evens. They're the ones that don't have the answer in the... So if you work on all the odd homework problems and you're checking your answers and you're doing really well, when you open up a quiz, it's going to feel like you're just doing more homework problems. Not for all of them, but for a lot of them. Comments and questions before we move on? I want to practice a couple things here. We're still going to work on section 2.2, and what I'd like you to do is I'd like you to partner up with somebody who's just sitting beside you. Everybody find a partner. You got 8 seconds to identify your partner.
All right, I have time to think.
We might have, if you have to work in a group of 3, that's fine. Although I think we have an even number in here. Even. Kiana, find yourself a partner. Kiana and Braden, you two want to... Oh, you're there. Okay. Even. You got a partner? Jack, right? Go sit back by Kiana so she's not so lonely back there. Take your computer with you. Okay. Here's what I'd like you to do. I'd like you to open up your GeoGebra grapher, and I'd also like you to have a piece of scratch paper out, okay? I'm going to jump to, I think it's example 2.14. See if I can find my... What we're dealing with here is plotting points, talking about slope, and graphing lines on a coordinate plane. Try it 2.11, see if I can find it here. Okay, I am looking at example 2.16 on page 136. And what I'd like you to do is I'd like you to be able to get kind of good at doing some of this on paper and also doing it on your computer and seeing kind of the benefits of both and what you can see. So I'm going to show you an example of how I would tackle something like this particular example. And then I'm going to turn you loose with your partner, and I'm going to have like one of you work it out on paper and the other one try to work it out on your computer and then share how you did it. And then switch. Does that make sense? That's why I'm putting you in partners. Okay. So it says, find the slope of a line that passes through 2 points. You guys might remember this from Algebra 1. Y equals mx plus b. That's just our standard form of a linear equation, a line, where m represents the slope. So it says find the slope of a line that passes through those 2 points. I'm going to talk about how we would do this with paper and pencil first, and then how we can do it on our computer. So if I want to find the slope between 2 points, remember we have that big ugly thing called the slope formula, which if you want to use the slope formula, that's fine. I tend to just say I'm just going to count boxes or do some quick subtraction in my head. So by definition, slope is rise divided by run. It's always a fraction. Rise over run, you guys knew that. So if I'm standing at this point and I go to this point, I'm standing at -1, a height of -1, and I go to a height of 3. Therefore, how much did I rise? Well, I rose a distance of 4, right? from -1 to +3 is a distance of 4. So if I'm standing at this point and I run to that point, how far did I run? From 2 to -5. -7. I ran 7 negative, right? So my slope is -7. You guys agree? Or 4 divided by -7. So that's the slope between those 2 points. I'm going to even take this example one step further, even though the example doesn't ask for it. The next question would be, what is the equation of the line in this form that goes through those 2 points? Well, I have y equals mx plus b. I just solved for my m, because that's what slope is, right? M. So now I have y equals -4/7 x plus b. But that's not my full equation. I need my b value, right? Anybody know how I want to solve for that? Yeah, just put in a point. I can use either point, either my first one or my second one. I'll just use my first one. So I have a y here and an x here. Well, y sometimes it's going to equal -1. And when that's true, x is going to equal +2. Now I just got to do a little arithmetic so I can solve for my b. -1 equals -8/7 plus b. I got to add 8/7 to both sides. So I'm going to have -1 plus 8/7 equals b. So what does that give me? -7/7 plus 8/7 is 1/7. So b is 1/7. So that tells me that my final equation is, hope I did this right, -4/7 x plus 1/7. How do you guys feel about that? So I'm going to keep that there. And now I'm going to write this down so I don't forget what the points were. 2, -1, and -5, 3. That's how I would tackle it on paper. If I wanted to use my computer to do this, I would open up like so. And I'm going to make the font size bigger for you here. And I'm going to say, okay, my 2 points are 2, -1, so I'm just going to plot that point, 2, -1. And my other point is -5, 3, -5, comma 3. And let me get it so I can see both of those points. Okay, there's my 2 points. And I'm just going to connect them with a line. So I'm going to go make a new line right there. Whoops. Undo. Okay, I'm going to make a new line through there. And notice GeoGebra spits out a line, but they spit it out in general form. So if I change this to mx plus b form, I now have y equals -0.57x plus 0.14. Well, if you take your calculator and you do 4/7 as a decimal, you'll find out that it equals that. And if you do 1/7 as a decimal, you'll find out it equals that. So I got the exact same thing on computer as I did on paper. What do you guys think? Know what you're doing? Okay. Figure out which one of you is going to do it on paper and which one's going to do it on computer. You got 2 seconds to decide. Don't worry, you'll get to switch roles in a second, okay? I want you to do this one right here.
I'm doing.
Try it 2.11. Not only do I want you to find the slope, I want you to take it one step further and I want you to find the equation of the line, just like we did on the previous example. So find the full equation of the line. One of you on paper, the other one of you on computer, and then when you're both done, share your answer and see if you agree. Oren and I will walk around and help you out if you run into any trouble. And if you find me staring at you holding this piece of paper, that just means I'm trying to learn your name. Bailey, where's Hannah? That's you. Okay, you're the one who switched seats up here, right? All right. See, now I'll remember. I'll say, Hannah, she's that seat switcher. Hannah. There we go. Emma, Katie, Modesta. Anybody finish? Both partners? If you did, I'd like you to share. Say, here's how I did it. And then the other person can say, here's how I did it. Okay, I worked it out, but I'm never confident. So if somebody else has an answer, flag me down. I'd like to check my answer against yours. Anybody got it? You guys got it? What'd you get? Negative 2/3 plus 4.6. Is that the same as 4.6?
Yeah.
Yes. Okay. All right. Anybody else? How we doing? Where's your negative 2/3? Excellent. If you didn't finish, that's okay. I'm going to show you what I did quick here, and we'll try another one. When I was solving it on paper, I wrote down my 2 points, and I just asked myself, what is the rise and what is the run? Now, you guys should figure out that I can call this one point 1 and this one point 2, and I could travel from this point to this point. Or I could call this one point 1 and this one point 2, and I could travel from this point to this point. The only thing you don't want to do is do a rise from, say, this point to this point, and then a run from this point to this point. You can't mix and match, right? So if I said I'm going from this point to this point, I'm at a height of 6, I want to go to a height of 4. How much rise is that? Well, it's a rise of negative 2. And if I'm standing at negative 2 and I want to run to 1, how far is that? It's a run of positive 3. So my slope is negative 2/3. Had I done it the other way, the negative would have been on the bottom, but you guys know that negative 2 divided by positive 3 is exactly the same as positive 2 divided by negative 3. Same thing. That's why it doesn't matter which point you use as your first one and your second one. So I know my slope is negative 2/3. So I go y equals mx plus b. I just grab one of my 2 points and I can plug it in. I chose the first point, but I could have used the 1 and the 4 if I wanted to. I used the negative 2 and the 6. I solve for b. You got to be a little bit savvy with fractions. And I get negative 2/3 x plus 14/3. Okay? If I was going to do that on my computer, I would plot the point negative 2, 6. And then I would go to, what's the other point, 1, 4? Okay. So there's my 2 points. I don't know about you guys, but I like to be able to see it. Like, I can see this written down on paper, negative 2, 6, and 1, 4, but it means more to my brain if I can actually see it plotted on a graph. So it just depends if you're kind of more visual or not. I'm going to connect it with a line. Now, we don't even have to look at the equation. If you want to just know the slope, let's say you didn't even care about the equation. You just wanted the slope. underneath this angle measurement drop down, you can measure the slope of a line. And I come over here and I click on that line, and it gives me negative 0.67. Again, this is going to spit out a decimal. When we did it on paper, we were getting a fraction, but we should know that 0.666666, that's the same as 2/3. Okay, so I got negative 2/3 as my slope. And again, they give us the equation in general form, but if I want slope-intercept form, I just right-click on it and I can change it into y equals mx plus b, and there it is. Negative 2/3 x plus 4 2/3, that's the same as 14/3. How do we feel? Good? Give me this is what we call gimme 5. Okay? You're going to raise your hand and you're going to throw up a number of fingers. 5 means this is easy. I know exactly what I'm doing. A closed fist is a 0. 0 means I have no clue. And then, or some number in between. Ready? Give me 5. Okay, I see lots of 4s and 5s. We're good to go. Let's try something a little different here. Let's go to, let's see, 212 and 214. Let's try, this one. No, we just did that. Let's try 2.15. Okay, let's look at this example 2.22. It says graph the equations of the lines and state whether they're parallel, perpendicular, or neither. Okay? You guys already know this. Parallel lines look like this. They do not intersect, right? Two parallel lines in the same plane do not intersect. They go on forever parallel. Why do they not intersect? When I look at their equation, what can I recognize about them? Same slope, exactly. And if they have the same slope, they're never going to get closer or further away as they go. So if that's parallel, you also know that perpendicular means they do cross, and specifically they cross such that it makes a right angle. Okay? So when I look at these guys, can you tell immediately just by looking at them if they're parallel, perpendicular, or neither? It's not real easy. What would make it easier? Yeah, put it into slope-intercept form. If I could get it into this form, then all I got to do is look for the m. And if the m is the same, they're parallel, right? If the m is not the same, they're not parallel. What would be the relationship of the two m's if they're perpendicular? Anybody know that one? Flipped and opposite. Very good. Flipped meaning reciprocal. So like if one is 1/7, the other one would be 7/1. Reciprocal. Flip the numerator and the denominator. And what's opposite? If one's positive, the other one's negative. If one's negative, the other one's positive. So it's what we call negative reciprocal. I can't spell today. Reciprocal. Did I spell it right? Or like Katie said, a flipped opposite. This is opposite and this is flipped. Very good. Okay. So I could get this into y equals mx plus b form, right? So if I divide by 3, divide by 3, divide by 3, this one is y equals negative 4/3 x plus 1. This one's going to take a little work. I got to move. Let's see. This would be negative 4y equals negative 3x plus 8. Divide by negative 4. This would be y equals 3/4 x minus 2. Okay. What do you think? Perpendicular. Yeah, aren't they flipped opposites of each other? So, again, that's on paper. Go ahead and try it on your computer. Try to graph these two guys on your computer and see what they look like. Now remember, when you're graphing on your computer, you can type them in y equals mx plus b style, or you can just type them in general form like they're written. So if I just wanted to do 3y equals negative 4x plus 3, I could just do that. And 3x minus 4y equals 8, I could do that. Notice on my screen, they're definitely not parallel. I mean, they're crossing each other, right? So that means they're not parallel. So the question is, are they crossing each other at 90 degrees? Well, it looks like 90 degrees, but we can't just trust our eyeballs, because what happens if I did that and stretched out one of my axes? It doesn't look like 90 degrees anymore, does it? So we don't just want to rely on our eyeballs for that kind of thing. There's a couple different ways. Remember this angle measure tool right here? You can measure an angle, select 3 points. Well, I don't have any points right now, so I'm just going to put a point on this line and a point on this line, and then I'll put a point right where they meet, like that. And then if I want to know an angle, I can go 1, 2, uh-oh, I did the reflex angle. I'll undo that. I'm going to go the other way. 1, 2, 3. And notice that my computer is telling me that that angle is 90 degrees. So 90 degrees means they're perpendicular. Okay. Go ahead and try the try it, which is try it 2.15. Switch roles this time. If you were on paper last time, I want you to use your computer. If you were on computer, I want you to give it a run on paper. Go ahead and double check your answer with your partner. See if you guys agree. So when I did both of them into y equals mx plus b form, I just solved for y, put it in mx plus b form, and this one was pretty easy. You should have found out that they both had the same slope, and the slope was 1/2, right? And when you graph them on your screen, obviously they are parallel. One of them has a y-intercept of 5, and one of them has a y-intercept of 2, so one's just above the other one. Give me 5. Okay, you guys are an advanced group. Very good. Let's check. Let's see if you can pull this off. let's look at example. Let's look at this one right here. Try it 2.16. I want the equation of a line that's parallel to that line that they gave me, and it goes through the point -1, -2. So they're giving me one line right here, and they're giving me one point. And then your goal is to find the line that is parallel. So let's say this is my line that they give me, and this is my point that they give me. I'm trying to find this line right here, the equation of that line. Go ahead and work together with your partner. If you want to do it on computer, do it on computer. If you want to do it on paper, do it on paper. See what you come up with. Remember, we're looking for the parallel line. The parallel line. Let me know when you have an answer. I'd like to come by and see if yours is the same as mine. Anybody got anything? What's the parallel line equation? Excellent. Anybody else? Very good. And if you wanted to change that guy into the other form, you'd right click on it and go mx plus b form, and it'll change the form. Excellent. Anybody else? Yeah. What'd you get? 5x plus 3. Good. When I did it on paper, I wrote down the line that they gave me, and I wrote down the point that they gave me. And I went and changed it into slope-intercept form so I could identify my slope, which was 5. So now I go over to this point. I know the line that goes through that point is also going to have a slope of 5 because parallel means same slope. So I just wrote in y equals 5x plus b. Now I don't know my b, but again, I can just substitute it in, right? Now some of you might be familiar with, and the book is going to show you this, what they call point slope form. Anybody heard of that one before? And I don't care what form you have. I don't expect you to memorize these. This is what we call slope-intercept form. Y equals mx plus b. That's probably our more popular version of a line. But they also do this one, where there's like y minus y1 equals m x minus x1 plus b. It's what they call point slope form. If you know one point and you know the slope, you can just plug the point in. I don't care how you do it. It's just moving the furniture around, doing a bit of algebra. I would rather you understand conceptually what you're actually finding, and then you can just work your way through it just with logic and reasoning. So I think it's going to be 5x plus 3 is going to be my my point. So if I go to my computer and I start with a clean screen here, They gave me the line 5x equals 7 plus y, so I'll type that in. 5x equals 7 plus y. I screwed that up. Thank you. 5x equals 7 plus y. Okay, so notice it spits it out in general form. I'm going to change it to mx plus b form. So there it is, 5x minus 7. Slope of 5, intercept of negative 7. But I want another line that goes through negative 1, negative 2. So I'm going to plot that point. So I want it to go through point A, and I want it to be parallel to this guy right here. Now, we can figure it out on paper, give it a slope of 5, blah, blah, blah. There's a little cheat on here too. Underneath your parallel and perpendicular lines here, notice there's parallel line. Look at that. The computer can do a lot of the computing for us if you haven't figured that out yet. So I want a parallel line. So I click parallel line. I'm going to click on my original line. And then now it's going to ask me, well, where do you want it? Do you want it way over here, way over here? Well, I want it to go through point A, so I'm going to click on point A. And sure enough, there it spits it out. I'm going to change it to mx plus b form, and y equals 5x plus 3 is what I was trying to get to, right? Go ahead.
You said when we do our test, we'll be able to use all of our resources, right?
Right, yep. So we're going to do some of this on paper. We're going to do some of this on computer. If you like doing a lot of this stuff on computer, then yeah, I'm going to let you use your computer. Now, it's almost to the point with the stuff that we're doing now, it's almost like the computer can do absolutely everything for us. Later on, we're going to get into some problems where we're actually going to start solving things where you can't just show up and plug something in your computer and turn your brain off. You know what I mean? You're going to have to figure things out. But yeah, I'm not going to take your computer away from you. So if you're really getting comfortable at plotting points and making lines and you like doing this on computer, then more power to you. Good question. Let's try one more. We got 3 minutes left. Notice that one said, here's a line and here's a point. Find the line that's parallel to it. How about we do it the other way? Instead of parallel, we do perpendicular. So here's example 2.24. This is right at the end, 2.24. It says find the equation of a line perpendicular to this line that goes through this point. So it's the same thing we just did. We're just switching the word parallel to perpendicular. See if you can figure it out. Okay, in the interest of time, since there's only 1 minute left, I'm going to show you what I did. Hopefully I did this right. When I did this on paper, I put it into mx plus b form. I found out that the slope of the line they gave me was positive 5/3, meaning the slope of the line that I'm looking for is negative 3/5. Opposite reciprocal, right? I got negative 3/5 x minus 7/5. Anybody with me? Yes? Could I do that on my computer? Yes, but we're out of time. So, what you should do is we're basically done with section 2.2. So you know you have a 2.2 quiz. You know that you have practice homework from 2.2. And when you come back on Wednesday, we're going to do some stuff that's a little more fun than what we did today, I think. So we'll see you on Wednesday.